inclined plane activity grades 1st through 2nd. So in your background information, you just want to talk about what an inclined plane does and how the ramp helps us. And in this activity, the students are going to explore how distance and the amount of force are changed when you use an inclined plane to lift an object. So just a reminder with the spring scale, just make sure that they know the rules about the spring scale and not to pull on the spring scale with your hands or place objects on the hook that is not related to this activity. The scales are very sensitive, and if the springs are damaged, the scale is going to be inaccurate. So here's your spring scale. Some of the materials that you need for this lab is a meter stick, a ruler, a bag of beans, and extra rubber bands, and some white sticker dots. So in here is just the activity directions, and then on the back of that page is the journal page that grades 1st through 2nd will be using. So the first thing that they're going to do is they are going to find a wall somewhere in the classroom. And what they're going to do is they're going to take their ruler and they're going to measure 10 centimeters. Okay, and then they're going to use their little sticker dot, find 10 centimeters and place a mark right there. And then what they're going to do is they're going to go ahead and take their spring scale and they are going to hook their bag of beans onto their spring scale, just like this. And they're going to lay it flat on the ground. And what they're going to do is they're going to lift the bag of beans 10 centimeters. So carefully what you're going to do is you're going to go ahead and continue to lift it until you get to that dot. And my spring scale reads 0.8 newtons. So what I'm going to do is go to my journal and lifting without inclined plane, 0.8 newtons. The next step is we're going to be using an inclined plane. So you can use your meter stick or you can use the ruler. But what the students are going to be doing is they're going to find that 10 centimeter mark and they are going to design a little ramp, also known as an inclined plane. And they're going to do the same thing. They're going to go ahead and try to lift the bag of beans. So usually you have like 2 or 3 people working with you. And what you're going to do is you are going to lift the bag of beans all the way to 10 centimeters. And then you are going to have a constant force. And my force on my spring scale reads 0.2 newtons. I'm going to go all the way to the 10 centimeter mark. Lifting with the inclined plane, 0.2 newtons. And there are going to be 4 questions that we're going to go over. Which method of lifting the bag of beans took more work? Well, without the inclined plane took more work. What is the advantage of using an inclined plane? Well, it helps us lift objects easier. They're going to draw their experiment below, make sure that they draw the beans, the spring scale, and their inclined plane, as well as the 10 centimeter mark. And number 4 is just another added question if you have time. If you increase the height of the inclined plane to 15 centimeters, will you need more or less force to raise the bag of beans? So if they have time, they can go ahead and try that. So again, they're going to measure 15 centimeters. There we go. And what they're going to do is first, they're going to go ahead and take their beans and they're going to lift it 15 centimeters. And this took about 0.8 newtons. Then they're going to go ahead and make their inclined plane and do the same exact thing and lift their beans up the ramp and come up with it.